The important thing is in the supersymmetric theory is the mass of the superparticle. Under such a superparticle mass spectrums determined by the two parts. One is the supersymmetry conserving part, and the other one is the supersymmetry breaking part. I will talk about how these superparticle mass spectrums are determined, and I classified both types of the some particle and the superparticle. The first one is the Higgs. That is because additional Higgs stabilized in the supersymmetric theory to explain the Upcock mass. So some Higgs mass spectrums will be changes in the supersymmetric theory. And there are the neutralinos and charginous, which is the mixing sort of the gaussinos and the Higgsinos. That is some of the baryon part. And the gluino, because gluinos does not mix it into the other gauginos and Higgsinos, so gluino mass is a separatist. And the other superfermions, including the superquarks and the leptons. The possible Higgs mass is determined by the scalar potential, and the scalar potential comes from the some superpotential and the mu term, and the some supersymmetry conserving part, and the source term supersymmetry breaking part. And we can calculate some of the Beckham's expectation of the scalar potentials to find the minimum value, and such a Higgs get the bab, so it makes some of the symmetry breaking to give some of the gaugeables of mass or some supersymmetry breaking impact. And we can obtain the mass eigenvalues and mass eigenstate in similar ways with this some given mass matrix in the tree level, and also some of the radiative corrections in the loop level will be this in the some mass of the Higgs, such as discussions will be applies to the other types of the mass spectrum. There will be some contributions from the Lagrangians, and we can construct sort of the mass matrix and obtain the some eigenvalues and the eigenstate. I mean, there's some mass eigenvalues and the mass height, and it is just a tree level. So we will develop the loop levels as the radiative corrections from the mass. So there will be also neutralino mass matrix and charginal mass matrix coming from some several contributions in the supersymmetric theory. And there's also gluino mass, but it's separated, so there's no mixing between the others. And also there will be some mixings in the superfermions, some flavor mixings between the different generation. And they also especially we talk about some Topcock mass matrix, which is third family, and some of the subsystem evolutions. So the point is there are some several contributions of the supersymmetric theory to determine the particle mass spectrums, and there are also renormalization groups evolutions of the such a mass, including the loop effect. And some of the mass spectrums are determined by some supersymmetric breaking model. So several parameters coming from the supersymmetric breaking is important things to determine the particle mass spectrum. That's a very important point in the supersymmetric theory. So first of all, let's talk about some of the Higgs. There are the two Higgs sublat. One is for the up type Higgs, and the other one is for the down type Kirk. And the scalar potentials consist of the many terms. Some terms that come from the supersymmetric conserving part, and some comes from the subsum. This second line, third line is the subsum, and the first term is a mu term. Some of the supersymmetric versions of the Higgs mass, so it provides such a part. And the superpotentials through the gauge interaction, there's some accelerability, and we can remove such accelerability because there's a no kinetic term, so it provides this such chaotic coupling terms from the gauge interactions. And there are scalar scared mass of some such a form, and also some bilinear couplings of terms. So there's both types of the possible contribution in the scalar potential. And there are two different sets of the parameters. One, the supersymmetric conjuging, comes from the mu term, that is the massive dimension parameter, and also some mass scales scales the mass of terms, and the parameter b also has a mass dimension, but this is just a supersymmetric breaking subsum. And the scales of the such mu terms and the subsum should be they have the similar scale. If not, there are some of the very large separations occurs in the mass matrix, so it's called the mu problem. The one solution of the mu problems is mu-terms as generated by the some supersymmetric breaking. So effectively mu-terms can be generated like some additional u1s times gauge matrix is included. So there are some Higgs from some Higgs superfield develop, and the charged part does not have the bulb, so it's just equal to 0. So the remaining part is just given like that. There are some neutral Higgs, HU geos and HD geo, and also we can see that some parameter mu terms and some subsum scales and b in here, and from the some gauge interaction term. So I will talk about some remarks on the some such as scalar chaotic interaction term here. If such a chaotic interaction term is a Jew, it can occur when the BEV of the HU Jews and HTUs, ATGUs is the same. So in these directions, such a chaotic interaction is a Jew. So because such a terms are coming from the D terms of the such a gauge interaction, so such a direction is called a D blood direction because the D terms are balances. So in the D term directions, there's a neo-chaotic term, so we should make the bounded below potential. So the remaining terms is some quadratic term, and such a mu and b, and to make the bounded below potential, the positive quadratic part is necessary. So this inequality to be should be satisfied along the D block direction. So it is called D block directions to make the bounded below scalar potential. And for electroweak symmetric breaking to give the gauge boson mass, the scalar potential has the non-zero bound, so it has such a forms of the potential. So at the geos, it has some local maximums, and at the non-zero bound, it has a local minimum. And for that, following the inequalities should be satisfied to make these negatives mass eigenvalue near the HU juiced and HD juiced equal to 0. If the one mass eigenvalues the negatives, then such local maximums at the juice can be appeared as shown in this figure. And now the remaining part is how the binding the some minimums the potential. We will set the Berkham expectation values of the HU juice and HD juice with the parameterization of the V and the angle beta. V is the same with the Bicommutative values of the standard model. And the tangent beta is the defines the light here between the VU and VD. And we can find the minimum of the potential by the first derivatives of the potentials about HUGU and ATGU. And we can find the two equations as functions of the some slope term parameter and the mu term, and also the betas, the light use of the two back mixed potential value. And from that, we can rearrange this formula with the beta and amjad about as a functions of the other parameters, subs parameter and mu term. So if we insert that such a mu term and subs parameter, then the alpha parameter, tangents betas and the amjad will be turning out. So we can assign the mass eigenvalues and the mass eigensizes of the Higgs. First of all, let's count the some degree of freedom. There are the two Higgs doublet, HU and HD. And because there's a doublet, so there's a two complex color field. So there's 8 degrees of freedom. There are 1 and 2, 3, 4, and also copies in here. And because electro weak symmetry is broken, so there are 3 massless non-Goldstone bosons will be appear. We will denote as G0 and G plus minus. So the remaining degree of freedom is 5, so there are 5 mass eigenside. There's a 2 CP even side, H small HGs and capital HGs, which is a CP even, and the imaginary part becomes a CP odd, will denote HO, and the charged part will be denoted H plus minus. So the mass eigenside is the small HGO, capital HGO, the CP even, and A0, CP odd from the imaginary part, and H plus minus charged part in the supersymmetric theory. So first of all, the neutral path, there's some bicomic factorization value non-zero, and the real part, and imaginary part, and the one imaginary part is a massless Goldstone bosons. And for the charged part, there's a no BAF is just equal to 0, so and one charged part is the massless. And the R is the representation of the mixing matrix with the angle alpha and the betas and beta plus minus. Alpha for the real part, and the beta 0 and the beta plus minus for the imaginary part. So from the quadratic parts of the potentials, we can assign the mass matrix, and if we diagonalize such a mass matrix, we can assign the eigenvalues and the eigensize. So first of all, mass eigenvalue, there's 3 number Goldstone boson, there's a massless, and for the CP odd scalar part is represented by the mu terms and some subparameter or the subparameter and the beta. And also CP evens and neutral part is given like that. And the charges parts are given like that as some functions of the other parameters. And notice that the HGO, small HGO, CP even, neutral Higgs is bounded above. There's a minus sign, so there's a bounded above, there's a minimum values of smallest HGO. And the mixing angle is given by the beta 0 and the beta plus minus. The mixing angle for the imaginary part is equal to just a beta, and alpha is given like that. As a function of the beta and some mass eigenvalues. This mass eigenvalues and the mass eigenstate mixing angle is calculated in the tree level for the Higgs doctors and the supersymmetric theory. And the loop corrections on the Higgs mass, the dominant contribution is the top curve here, and the top curve. these two diagrams, and this is also related to the hierarchy or natural nets problem. And the contributions of the such a mass corrections can be written as some Yuga coupling, the T coupling is in here, and some scales of the top cook and the top cooks and the mixing angle. And also the corrections can be appears by the Carty coupling, like that. Some of the star Laptons and the Higgs. The theory marks because barometer mass and the mixing angles as loop corrections, it can be related with the background fluctuation values of the Higgs. And also the Higgs and the boson coupling, HWW and or HZ is dependent to the mixing angles or the tangent patterns.